All right, here's 4, 4. Day 1. The focus is kind of moving from basically like quadrant 1 on the unit circle, which is more or less where we were in section 3, and now really trying to broaden stuff up to the point where we can get some trig values, kind of for any, as the title says, for any angle at all. Okay, I want to give you a kind of a general outline as to how this works. Let's say you've got an angle over here in quadrant number 2. That point that I plotted has an x value and a y value, and it determines what the angle is, like how big it is. Okay, wherever you put that point, that will dictate the angle. Now, notice I can't set this up inside of a right triangle because it's bigger than 90 degrees. Like, it's in quadrant 2, so this angle is somewhere between 90 and 180 degrees. So that all that stuff from section 3 about opposite over hypotenuse, adjacent over hypotenuse, I can't really use that because that terminology is really specific to right triangles. But notice here, that side length is x, that side length right here is y, and let's say the distance from 0, 0 to the point that we plotted is r. There's a right triangle that really is related to our angle. All those measurements are going to be, the same. If we're talking about, this angle theta, those numbers are going to be unique to our angle. Okay? So here's what we really have to do is just kind of switch the terminology. How would we talk about theta's sine value? Okay? Now this little angle right in here, I'm not going to get to this until the second day. That is a really significant little angle. We call it a reference angle. Okay, we'll get to that later. But if you want to think of this whole situation from that angle, you really can. Okay, and from there, it kind of seems like the y, I use this terminology loosely, that's kind of like the opposite. X is like the adjacent, and of course r is like the hypotenuse. Now keep in mind for the rest of this section, we're not going to use those terms. That's really what I'm trying to address right here. Sine, but when you relate it to those terms, I think it's easier to see that sine is y over r. Cosine is x over r. And then tangent is y over x. Now if we go back to section 2 when we were on the unit circle, this might look a little bit familiar because we actually used the same notation. The only difference was if we were on the unit circle, we give r the value of 1 right here. Okay? R would be 1. That's not the case anymore. R doesn't have to be 1 because wherever we plotted this point to form the angle, it may not be on what we would call a unit circle. And then, of course, for all the reciprocals, we've got cosecant. That's going to be r over y. Secant ratio, which would be r over x. And cotangent, which would be x over y. Okay, so that for the rest of section 4 is really the notation that you're going to see me referring to, and that's what we're going to use. So let's dive into one of the problems that we would see. Okay, something like this. All right, so this point that forms our angle is going to be negative 3, 4. So I'd go 3 units to the left, 4 units up, I'm going to plot the point right there. My initial side is never going to move. You know, and really on this one, this example is going to look a lot like the one that we were just talking through, but now we've got some numbers. We're going to deal with some nice numbers on our first one. Okay, there's the right triangle that's formed. This side is -3. Now this gets a little bit weird because normally you're like, do we think of that as like a side length of a triangle, because, you know, side lengths can't be negative. If it's an x, like if it's one of the x and the y coordinate points, then you need to think about the positive and the negative, and the sign is really important. It's not for r. Okay, the Pythagorean theorem here of doing 4 squared plus -3 squared. Okay, you solve that and you would get 5. R is always going to be positive. We'll talk more about that on the next slide. But once you have a diagram like this set up, keeping in mind here that this, -3, is what we would call our value for x, and 4 is what we're going to call y. If you go back to the list of our 6 trig functions, once we get to this point on our diagram, we're set. We are set and we are good to go. Okay? Now, I'm not going to do the reciprocal ones because, you know, you can kind of figure those out as you just, you know, flip each of these 3 trig functions. Sine is y over r, and once you have your diagram, this part should be a breeze. You're just plugging in what those values are. Cosine is x over r. Well, that's got to be -3/5. Tangent is y over x, which would be -4/3. Okay, so really, as we move to a couple problems that are a little trickier, you're going to see the same thing, that what we're aiming for is to draw this diagram. Okay, because once you have that diagram completed, then you're in really good shape. Now here, I don't know why I drew 2 of these. You really don't need 2. I should fix that. If you want to, I'm going to slide this over a little bit. If you want to, you could take one, you know, if you have the notes packet, you can just cross that one out. You don't need it. I meant to just put it down to 1. So here's what you want to do. As you're working your way around, depending on your quadrant, you want to pay attention to what's going on. All right? Are you dealing with trig functions that are positive or negative? This is something you want to be thinking about constantly. Okay, because there's typically a combination. Other than quadrant 1, which is just wonderful because x and y are positive. Okay, so here, and you can always think of these as pairs, right? If you're talking reciprocals, you know, as far as the sign of being positive or negative, sine and cosecant are always going to go together. They can't be different signs. And in quadrant 1, they're going to be positive. Cosine and secant are going to do the same thing. And then tangent and cotangent. Right? Again, quadrant 1, those are problems that involve angles that could be set up in a right triangle. Everything's great in quadrant 1. It's always positive. Okay? Now over in 2, our x-coordinate becomes negative. Now keep in mind, in quadrant 2, well, really any of the quadrants, you're always free to associate the x-coordinate with cosine. Okay? So now we see a little bit of a change here that for negative, here's a case where cosine and secant are both going to be negative. Okay? Over here, however, for the positive, you will have sine and cosecant, because that is associated with your y-coordinate, which is positive. Now, one thing I should have made more clear, and it now becomes an issue for us. I mentioned it earlier, but now let's make it official. R is always positive. Okay, that you can think about a distance from the point that you plotted to the point 0, 0, and it's always positive. Okay, now for tangent and cotangent, that's some combination of x over y. Well, x over y or y over x. So you've got a positive number and a negative, and that is going to give you a negative trig value. So we go over to quadrant 2, and 4 of the trig functions now take on negative values. Okay? Down in quadrant number 3, you might think that it's always going to be negative because both coordinates are negative, and it almost is. Sine and cosecant are negative. So is cosine and secant. But here's something that's kind of interesting. If you're dealing with a tangent or a cotangent value, you have a negative number. And again, this is unique to angles that are in quadrant 3. Okay, so if we're talking in degrees, these are to be angles that are between 180 and 270 degrees. You're dividing two negative numbers, which would give you a positive. So here in quadrant 3, tangent and cotangent values are actually always positive down there. Let's hop over to quadrant number 4, which is positive and negative. Okay, for negatives, you're going to have sine and cosecant. Again, there I'm looking at the y-coordinate, and it's negative. Tangent and cotangent, we're back to having one of each. That's going to make those negative. And then I look to that x-coordinate, and I see that it's positive. So down here, cosine values and secant values are going to have to be positive. All right, so my goal here is similar to the first example that we worked through. And I want to immediately make it clear that what I'm after is a diagram. Okay, but now this one's making it a little bit trickier because this doesn't tell me the point that forms my angle. It just tells me its tangent value. And this is really in light of what we just talked about with, you know, the sign as in positive or negative of a trig value. It becomes a really big deal, you know, as to where you are. Because if I want to answer this question of, you know, my angle theta, what's its sine value? What's its cosine value? If I get my diagram, it's a pretty easy question. It really is, right? Y over R and X over R, excuse me. Not giving any love to the reciprocal functions. I'm getting two of them, sine, and the other one must be cosine. Not so fast. Sine and secant. It doesn't change how I'm going to do it, okay? I need my diagram with X, Y, and R, okay? But what I want to take you through here is, you know, doing it with a little bit less information. I'm going to notice, like right here, okay, that's really significant that we've got a tangent value that is negative. We've got a tangent value that's negative. Okay? Now, if you refer back to that last slide that we just did, that tells me this angle is in one of two spots. It's either in 2 or it's down in 4. Okay, now that's not enough to do it on its own. That's why it's also telling us this. Our cosine value is positive. So now I look at between 2 and 4. Again, going back to that diagram that we just looked at, and I see that cosine values in quadrant 2 are negative. They're positive down in 4. Okay? So now, and my sketch obviously doesn't need to be real perfect here. I mark my point here. I don't really care that it's super accurate, just so long as that it's in quadrant 4. There's angle theta. it's somewhere between 270 and 360 degrees. I don't exactly care, what it is, because my goal in this problem is to just then find its sine and its secant value. But now I'll set up the rest of my diagram, but I have a good sense of where I'm at. Okay, y over x, this is going to have to be -5. X is going to have to be 4, and that makes sense, right? Down in quadrant 4, x should be positive, y should be negative. Oh, and then a little Pythagorean theorem work right here that we, for r, would get the square root of 41. Okay, which would come from 4 squared plus -5 squared equaling r squared. Okay. And now once we've got that, we're good to go. Okay. Our y value is -5. Our r value is the square root of 41. Just go ahead and rationalize that to get -5 square root 41 over 41. Okay. Secant is r over x. R is the square root of 41, x is 4, and there you go. Okay, the work was figuring out what quadrant I was in and then getting my value for r. Once you have your diagram drawn, getting trig values is pretty straightforward. Okay, because at that point you've got x, y, and r. All right, now down here, just a quick word to finish. So with these diagrams, I've kind of talked about how, it's to get x, y, and r, but we draw them out so that you set up this little right triangle that's really related to your reference angle. And again, I don't want to go too far down that road with reference angles because that's day 2. So the quadrant angles can be a little bit tricky. I'm talking about here, right, I'm just going to talk radians, and here, if our angle is at pi over 2, here if it's at pi, and then down here if we're at 3 pi over 2. Okay? Now that point would determine our angle. Okay, so if my point is right here at 0 radians, I have an x coordinate, and I know it's positive, and I know my y value is 0. Okay? It would look something like that. X could be really any number. Okay? But now there's no way to even construct a triangle, so what can get a little bit confusing is what do you do with r? Okay? R would then be the exact same thing as x, okay? Which actually fits the definition of R, which is that from the point that determine your angle, it's the distance from that point to the center. If you're at 0 radians, that distance r and your x coordinate just happen to be the same number, okay? So now go up to pi over 2, where we know x is going to be 0. We're going to have a positive y value, okay? And really the same thing happens, but here r is going to be the same thing as y. What I'm trying to show you here is even if you're at one of your quadrant angles, it's all about getting x, y, and r, okay? R is going to be related to either x or y, and at these 4 angles, either x or y is also going to be 0, okay? Now let's go over to pi, where things get interesting. You'll have an x coordinate, you know that it'll be negative, and you're going to have a y coordinate that you know is 0, okay? It's really the same case as 0 radians, but now we just went over to the left. So once again, the issue becomes, what about r? Well, if we follow the same case as before, isn't it the same thing as negative x? And almost. Remember we said that r always has to be positive? So make sure to just take the absolute value. If x is negative 5, y is 0, then r is going to be 5. All right? Really similar situation down here. If we're at 3 pi over 2, x is going to be 0. We're going to have a y-coordinate that's going to be negative, and you've probably figured out the pattern at this point that r is just going to be the same thing as the absolute value of y.